So let's do some extra practice on naming organic compounds. If you were given the name heptane, you would recognize the root, which indicates 7. 7 carbons, 1, 2, 3, 4, 5, 6, and 7. And this is a hydrocarbon completely saturated with hydrogens, and we'll draw those in. And I'll forgive you for not drawing the bonds to the H and just drawing in the hydrogens themselves, because I do that too. That would be the structural formula. The line angle is your first carbon, second, third, fourth, fifth, sixth, and finally 7th. This is, of course, condensed structural. We would write CH3, and I would write CH2 1, 2, 3, 4, 5 times, or quite simply, I would say that that repeats 5 times and indicated like that, and then put a CH3. And as a molecular formula, because that's condensed structural, molecularly, I would just write CH. This is heptane, so it's C7. 2 7s are 14, and 2 more is 16. And that's that. The next one we had on our list was 2-methyl-1-pentanol. This is an alcohol type or class of molecule. It is 5 carbons long. The OH group is on the first carbon, and a methyl group is on the second carbon. So I would draw it. 1, 2, 3, 4, 5. I always want to start with just what I've been calling the backbone, or the open chain, the number of carbons corresponding to the root. Well, and then you want to put your groups on. So on the first carbon, I have OH, and on the second carbon, and we'll point it in the other direction for room, we have a methyl group, CH3. And then let's draw the bonds to my H's in this case. I have to squish that one in there. The condensed structural formula is CH2OH, and then my next carbon has only 1 hydrogen, but also a methyl group attached. Putting it in brackets tells me that it's not part of this chain, that it's actually a pendant group belonging to the carbon that comes behind it. And then I have 3 CH2 groups. Or do I? Hold on. No, just 2. So 1, 2, 3, 1, 2, 3, 4, 5. That's my condensed structural, and my line angle is 1, 2, 3, 4, 5. With on carbon number 1, I have an OH group, so I'm just going to stick it out here. And on carbon number 2, I have a methyl group. Oops. And then we'll stick it on here, just like that. Oops, sorry. There you go. I'm going to skip over the molecular formula because that's just adding up your atoms. The next one we had on our list was hexanoic acid. And you can't see what I'm writing. That was the next one on our list, hexanoic acid. And again, I can tell that it belongs to a class of molecules or type by that term here of carboxylic acids, and I know that there's a 6-carbon root. and that last carbon is part of the functional group, and the rest are hydrogens. And so this is my structural. My condensed structural is CH3, and then 1, 2, 3, 4. I didn't do this in class, but clearly it doesn't mean that 4 CH2s are branching off of this carbon, because simply can't make that many bonds, so I don't think it's confusing to write it that way. 4, and then my group. You can also write that as CO2H. And the line angle form of this, again, 6, so I'll start 1, 2, 3, 4, 5, 6, not very straight, and hexanoic acid. Like so. And I have drawn it the other way in class. 1, 2, 3, 4, 5, 6, and done this. This is the way you should be doing it, and this is okay for this class, for this test, but this is really the way that you should be doing it. The next molecule we had was fluoroethane. Fluoroethane. Ethane has 2 carbons. We'll stick a fluoro on there, and the rest are hydrogens. And that's all. We'll say that's CH2F, CH3. We know this guy is not inline, part of the backbone, like it doesn't go carbon, fluorine, carbon. So you don't have to put it in brackets. It's not necessary. Oh, sorry. What's next on our list? 3-chloroheptanoic acid. So this is another carboxylic acid, and the root there is HEPT, which indicates 7 carbon. The carbon number 1 will be part of a functional group at the end, and carbon 3 will have a chlorine on it. I'll do it here. 1, 2, 3, 4, 5, 6, 7. That's carbon 1, 2, 3, chlorine. The rest have hydrogen, so if you're asked to do the structural, don't forget to draw those in. Condensed. That could have been written COOH. These could have been coupled as a CH2 repeated 3 times, and this chlorine did not have to be in brackets. So we're just mixing it up to show you the different ways. And in terms of a line angle, 7 carbons. 1, 2, 3, 4, 5, 6, and 7. Again, this carbon that's here at the end is actually part of the functional group. And so there's a double bond to an oxygen, and a single bond to an OH. That is now carbon number 1. So carbon number 2 and 3 is here, and 3 had the chlorine. What's our next one? 1-bromo 2-fluorooctane. Let's stop there. I'll make another one for the next couple.